The Órbigo River project has been implemented by the Spanish Ministry of Agriculture, Food and Environment through the Duero River Basin Authority, in compliance with the Floods Directive and the Water Framework Directive and their respective goals of reducing the negative effects of floods and improving the ecological status of water bodies. The idea behind the project was that by restoring river connectivity with the floodplains, the hydraulic capacity of the river in the event of flooding would be vastly increased, since it would be able to absorb more water in a controlled manner. In turn, through restoration of this connectivity, various natural processes would be re-established that would lead to ecological improvements. In summary, the project consisted of removing all of the existing defensive structures along 23 kilometers of riverbed, or setting them back beyond the floodplain, depending on whether land use in the floodplain was compatible or not with flooding. In the case of setting the structures back, the location of the new defensive structures was selected on the basis of hydrologic and hydraulic studies in such a way as to exploit the maximum hydraulic capacity of the floodplain to abate floods, respecting and thereby increasing the protection of areas occupied by populations. Until recently, the technique used to protect an area from flooding was to confine rivers within very narrow channels, which gave a full sense of security. This type of solution increases the speed and height of floodwaters within the channel, generating very high levels of pressure and erosive forces, and posing an unacceptable risk in the event that the defensive structures are breached. If floodwaters exceed the hydraulic capacity of the channel, the water will overflow with much more force than that of a natural flood, allowing vast quantities of water to inundate the very areas that the defensive structures were intended to protect. The collapse of containment structures exacerbates the damage caused and even prevents the water from returning to the river, provoking major, more long-lasting flooding and thereby increasing risk. Technically, setting defensive structures back is not a complex procedure, but it requires perfect planning of tasks on the basis of two premises. Before removing the obsolete structures, the new ones should be fully functional, and secondly, the materials used to construct the new infrastructures should come from the old ones, so that any intervention maintains the safety of the population and minimizes the need for new materials. The exterior of the dike is composed of lightweight materials that will support plant recolonization, thus integrating the structure into the landscape. The very large stone blocks laid at its base are placed below ground level to prevent the current from moving them and causing the entire structure to collapse. Lastly, in those areas where this is necessary, the face which will be exposed to the river is clad with smaller stones to solidify and strengthen the entire structure. In the new approach to flood risk management, however, defensive structures are moved as far away as possible from the river bed in uninhabited areas, restoring the river surroundings and allowing the floodwaters to spread slowly and in a controlled manner over the floodplain, favouring a natural phenomenon called flood abatement. During flood abatement, when the flow increases as a result of a flood and the floodwaters occupy agricultural and forest areas for a limited amount of time, but do not rise as high or flow as quickly, which in turn benefits the inhabited areas, which are thus exposed to less risk of flooding. Although the spread of floodwater across floodplains occupied by forestry and agriculture does not present a threat, interventions affecting inhabited areas and their immediate surroundings require a different kind of planning, which must necessarily have the support of public opinion. Thus, months before implementing this project, the Duero River Basin Authority technicians began an information and citizen participation campaign within the affected municipalities in order to address the doubts and uncertainties identified regarding the safety of the riverside population. A hydraulic simulation was used to model the behavior of a large magnitude flood, an event which will on average happen at least once every 50 years. For the situation before the project, the computer model predicted that the increased flow generated by the flood would not be retained by the obsolete defences, causing the water to invade urban areas. The approach taken with the new project has made it possible to clear the river area of obsolete and inefficient structures that were impeding recreational access to the river, and to construct a new line of dikes within the urban boundaries, so as to maximise the safety of villages with respect to flooding, whilst at the same time improving the visual, recreational and ecological quality of the area. Thanks to this computer model, we can simulate what would happen today if the same level of flooding occurred around Carrizo once the defences have been set further back. The red line represents the new chain of defences constructed to contain a flood of up to 35% higher, while the yellow line depicts the old chain of defences. When the flood reaches the area, the water crosses the former defensive line easily, but hardly touches the modern line, because there is now sufficient space for it to spread throughout the width of its channel and into some wooded riverside areas. Once the work has been completed, this stretch of the Órbigo River will become a benchmark in sustainable socio-economic development, where the naturalness of the river area will constitute another economic asset, and in which the desired level of protection against flooding will have been definitely achieved.